The examination for Dynamical Systems of Chaos for summer 2015. So these are the solutions. You have to answer 5 questions. If you answer more than 5, we'll take your best 5 solutions. And the exam will take place in a computer lab with MATLAB installed, and you are allowed to use the MATLAB help pages during the examination. So question number 1, you have to sketch a phase portrait for this linear system, and question 1b, you have to find a Poincare return map for this planar system. So for 1 part A, here is our linear system. To find critical points, we solve dx dt equals dy dt equals 0. And you can easily see there's only one solution, and that's x is 0, y is 0. The Jacobian is given by 3, 4, and the second row is -1, 8. We can use MATLAB to find the eigenvalues and also the corresponding eigenvectors using the vect_val equals eig of A, or eig of J in this case. Both eigenvalues are real and positive, so this is an unstable node, and here are our vectors, the eigenvectors, which give the manifolds. The isoclines are given by y is -3x over 4, so that's from this expression, x dot is 0, gives us vertical flow, and y dot is 0 gives us y equals x over 8, so that's -x plus 8y is 0, gives you y is x over 8. Now I haven't put the isoclines on here, but in the examination you would have to sketch the isoclines. You would also sketch the phase portrait in your answer booklet. So here is the eigenvector 1, 1, so that corresponds to the unstable eigenvalue 7, and here is the eigenvector 4, 1, and that corresponds to the eigenvector 4, eigenvalue 4. For part B, here we've given this planar system. We want to determine the Poincare return map, so we need to solve for r and theta. So we integrate. So we integrate 1 over r minus 1 squared. This is just simple A-level mathematics, or you can use MATLAB and you get -1 over r minus 1. If you integrate 1 with respect to theta, we get theta, and you integrate 1 with respect to t, we get t. And then we add our constants of integration. Now we're given that initially r is 2 and theta is 0 at time t is 0. So we substitute those values in, and we find that c1 is -1 and c2 is 0. So substituting in here, we have r is equal to -1 over t minus 1 plus 1. But we also know, because this is Poincare return map, theta is the same as t from here, and that will be equal to 2n pi, because we need 2 pi returns to get the Poincare map. Now r subscript n, so theta, remember, is 2n pi, is equal to this expression, so r subscript n plus 1 is -1 over 2, and then n plus 1 pi minus 1. And then we can use simple algebra to find an expression for r n plus 1, because we know we've got an expression for in terms of Rn here. So I'll let you prove that yourselves. And that concludes the solutions to question number 1.